Okay.
So, welcome everyone. This is the Lake meeting at ITF 125. Hello to all the remote presenters from Shenzhen. My name is Malisha and my co-chair is Renzo. Since we are the Monday of the ITF week, we should take a moment to take care of the Note Well. Note well covers the IETF contributions, and all the contributions that you make with respect to this meeting are considered contributions to the IETF standardization process. Please be respectful to each other and behave in a professional manner. If you are aware of any patents, you are required to disclose them following the note well. This meeting is recorded, so we are taking notes. I believe we already have at least two note takers, Marco and Giovanna, and I would like to thank them at this occasion for their availability. So on-site attendants, please sign in using the Miteco on-site tool by scanning the QR code such that your presence is logged. Remote participants, please make sure your audio and video are off unless you're chairing or presenting during the session. So here are a couple of resources for today's meeting. We have a packed agenda. So I will be going through this in a moment. I took a moment to recap a little bit because we have a couple of newcomers in the meeting. So to recap what the working group is about. So at a Lake working group has standardized at the ad hoc protocol RFC 9528, a lightweight authenticated key exchange protocol. It was standardized, I believe, 2 years ago as an RFC in RFC 9528 and RFC 9529. The ad hoc protocol targets constrained IoT use cases such as BLE, 6-dish, IEEE 802.15.4, LoRaWAN, and other applicable use cases. It was developed in synchronization with the formal methods community by launching different formal analysis calls in parallel with the standardization process in the IETF. We will see that how that process works in action during this meeting, as we will be hearing multiple presentation on formal analysis related to the ongoing drafts of the Lake Working Group. Ad hoc is deployed. I provide here a pointer to a blog post that we wrote on ad hoc and some deployments that we are aware of. More information, implementation, formal analysis pointers, etc., are available at lakewg.org. It's a Confluence page that we, as chairs, try to maintain to the extent possible. Of course, if you see anything outdated on that page, please let us chairs know, and we can update the page, or you can update it directly by clicking, by anonymously editing the page. Current work in the Lake working group considers re-keying and pre-shared key-based authentication, remote attestation, third-party authorization, implementation consideration documents, etc. And we will be seeing more of these during the meeting today. So that would be it for the recap. Right now on the status, so all the 6 of the active adopted documents got recent updates for this IETF. So I thank the editors and the draft authors for their reactivity. Today, 5 of them will be presented, and so the documents will be presented, as well as formal analysis presentations for 2 of them, because we recently launched the formal analysis for pre-shared key-based authentication draft during the last IETF meeting, after the last IETF meeting in Canada, sometime in November 2025. Apart from the adopted documents, we have 4 individual drafts that will be discussed at this meeting. And I would like to take this occasion to thank Paul for serving as our AD and for doing the bulk of the work on the rechartering of the lake. As a reminder, the new lake recharter allows us to standardized new ad hoc methods that includes CAM authenticated ad hoc methods, as well as to perform maintenance on the protocol to standardize new cipher suites, which includes the work on reducing transport overhead. One document that is not discussed in today's meeting is the Greece document that is led by Christian. He kindly provided a hackathon report in the form of a GitHub issue, which you can consult at this page. And in consultation with Christian, we will be launching a working group last call after this meeting on the Greece document. We expect a multiple working group last calls to be launched at this meeting. So for note takers, it would be appropriate to maybe make a section in the notes on the working group last calls, and we will need to agree on the order in which we will launch working group last calls, as this is the best practice of the working group so far, such that we do not overlap the documents and we give enough time for reviewers to review individual documents during the working group last call. So I'm already a little bit over time and we have a packed agenda. So this is what the agenda looks like. Do we have any agenda bashing on this agenda here? So I hear none. So I suppose we will be going on with this agenda. Okay, thank you. So so this will be for any other business. With that, I propose we get going with the first slot, which is the formal analysis of draft Lake ad hoc PSK 06 by Dekra. Dekra, can you hear us?
Yes, I do.
Okay, let me just share the slides. So I'm trying to find you in the participant list to pass you the slide control. Can I do this here? No.
I just give to Dekra,
Okay.
I think.
Okay, perfect. I couldn't find her in the participants list. That's perfect. So Dekra, you have 20 minutes. Please go ahead.
Okay, thank you, Malisha. So I am Dikra Mahmoud. I am a postdoc researcher from a lab called Limos in France, and I basically work fully on the formal analysis of security protocols. Okay, so as Malisha mentioned, so the ad hoc PSK is currently under standardization, and the Lake Working Group called for formal analysis, and here we are. Okay, so before going through the formal analysis, let me just give you a quick reminder regarding the ad hoc PSK protocol. So it involves an initiator and a responder. They both share a symmetric secret key beforehand. And in the first message, the initiator is going to create his own ephemeral Diffie-Hellman key, which is here g to the power of x, and the responder is going to process the message and send and create his also ephemeral Diffie-Hellman key g to the power of y. In the third message, the initiator is going to use his PSK in the message. So upon receiving this message, the responder is going to authenticate I, and um, the initiator waits to the last message from the responder in order to authenticate him, right? And after actually this exchange, so a session key called PRK is going to be created, right? So here you only need to recall that it's based on a pre-shared key, and both of them needs an identifier for the pre-shared key called ID cred PSK. I'll go again to this ID cred PSK maybe later. Okay, great. Now regarding the form analysis in the symbolic model. So in this particular approach, we consider that cryptographic primitives are perfect, meaning that there is no cryptanalysis attacks, there is no side channels attacks, meaning that we need only the secret key in order to decrypt. I mean, the only way to decrypt is with the secret key, right? So the protocols also needs to be encoded in a formal language, right? It depends on the tool, or it depends on what formal language that we choose. The attacker is considered the full network, and generally speaking, we consider the worst case. I mean, it's an active attacker who can intercept, play replay messages, delete or block messages, and also inject messages of his own. We can also add some particular compromises capabilities for the attacker. In this work, we added the compromise of the PSK, we added the compromise of the Diffie-Hellman secret keys X and Y. We added also the possibility for the attacker to compromise the session key, and we also added a capability at infinity of the attacker, which is a discrete logarithm oracle. So why here at infinity? Because we considered in our formal analysis unbounded number of sessions and unbounded number of participants. That means infinite number of sessions. So the oracle only need to be deployed, I mean, at the very end or after the protocol executions. The security protocols also should be expressed formally, either as reachability or derivability properties, or trace properties, or equivalence properties. So in order to have a model, and when we talk about a model in the symbolic, in formal analysis, so we talk about a model of the protocol, a model of the primitives, a model of the attacker, and a model of the security property. And the modeler actually, yeah.
So we have some in the queue. Would you like to take questions now or at the end of your presentation?
Maybe at the end, because I'm going back to all of them.
Okay.
So, the model actually has the freedom over all those properties. So for those who consider that designing security protocol is actually hard, also verifying security protocols is actually hard, because if there is some details missing in one of those features, then we may have different results. Okay, so I think maybe all of you have heard of the mainstream protocol verifiers, Tamarin and Proverif. Also, the choice of the tool is important, because they may give different results. So in 2022, we have this paper called SAPIC Plus Protocol Verifier of the Word Unit, where they introduce a new framework from which we can, from one model of SAPIC Plus, we can generate two models, one for Tamarin and one for Proverif, and we have the soundness over the protocol model, not over the primitives, not over the security properties, but over the protocol model, in order to be able to work on it with both tools. So here, maybe my table is not fair for Proverif. It seems like Tamarin checks all the marks, but this is not true. Proverif, generally speaking, is more efficient and is very fast compared to Tamarin, but Tamarin is more precise. Okay, so now let's see the claimed and formalized security properties for the ad hoc protocol. So there is this confidentiality of the session key, and we formalize it different ways. So we formalized secrecy of a session key from the initiator point of view and the responder point of view, since they may not agree on the same session key. We formalize also secrecy upon agreement and forward secrecy. Also, mutual authentication and explicit key confirmation was claimed. So we formalized the authentication of the initiator to the responder upon receiving message 3, and the authentication of R and I upon the receiving of message 4. So regarding the properties that we formalize as equivalence properties, so we can see that it's called identity protection. We formalize two flavors of identity protection, namely anonymity and unlinkability. Anonymity of a participant just means that the attacker won't be able to extract or to know the identity of either the initiator or the responder when the protocol has been executed. And unlinkability means that even though the attacker doesn't know the identity, can the attacker actually link sessions to the same identity? Okay, now let's see the table of the results using Tamarin and Proverb with trace properties. So here I put the minimal compromise scenarios that are needed to break the security properties. And this table can be, we can read it at the following. For example, the PR key secrecy upon agreement can be broken either in the active case, either if the attacker has BSK or X, which is the ephemeral key, or PSK and the other ephemeral key, or simply if the attacker compromises the PR key. We can see here that PSK is basically everywhere. That means that it acts like a defense mechanism to all the properties. But we can see that the forward secrecy is not achieved if we consider discrete logarithm oracle. Okay, so the minimum compromise scenarios for the identity hiding properties. So we can see that the unlinkability of the initiator in the passive case can be broken either if the attacker knows one of the ephemeral keys, but if the attacker has an access to a discrete logarithm oracle, then there is no unlinkability of the initiator, and also there is no unlinkability for the responder considering a passive attacker. And in this particular case, Proverb actually outputs a counter example for the unlinkability of the responder, considering a passive attacker, which is actually very, let's say, obvious. If we have one responder executing the protocol with maybe multiple initiators, and on the other hand, this execution should be indistinguishable from having many responders. And if the initiator actually just broadcasts messages, then at some point, in the case of we have many initiators, many responders, so the protocol would fail at many points since the authentication of the responder only happened in the last message. However, if we have only one responder, we are always having message 4 everywhere. So the protocol would never fail and the attacker would able to compare those scenarios. Okay, so before taking the questions, I'm going to say that are we done with the formal analysis? I would say no, because we can add many features to our models. So here I put what we can integrate immediately. For example, more precise model of the XOR, also add more algebraic properties of the Diffie-Hellman exponentiation in Proverb. And more importantly, so for me, we need to replace the Diffie-Hellman with a standard KEM model to see whether if the KEM actually, behaves exactly like the Diffie-Hellman or not. Also, we need to, there is those security properties as called unknown key share attacks that we need maybe to model, such as bilateral and unilateral case. For the next steps, but not immediate, those are more complicated features. So I put here some ideas. So for those who want to collaborate or for those who want to make their models, so it should be great to add those features. Thank you so much.
Thank you, Dekra. So we can take questions now. So we have Osama in the queue. Osama, do you want to go ahead?
Yeah, sure. Thanks very much. It was very interesting and great to see that the working group is going into more and more formal analysis. That's really nice to see. If you go back to fourth slide, I just a clarification question. So replay delete, inject, that all is fine. So I just want to understand intercept that. So at the top, you are saying the network as the worst case. So intercept would just be a passive listener. It wouldn't
Yeah.
be active one, right? Okay.
Yes.
Okay.
Yes.
Thanks.
Exactly.
Okay, and in the next slide, I work a lot with ProVerif. I do have concern about this. I think it's not a fair comparison, as you also kind of agreed,
Yeah. That's what I said.
because yeah, I mean saying maybe it's not enough because your slides are there, so and people can misinterpret it. The thing is that it can be useful in many cases where Tamarind will get stuck and so on, and you need to move to some tool where you can still get some results with some approximations maybe. But anyway, so in the next, I think 6 or 7 slide, you had minimal.
Yeah,
Um,
wait, but I mean, what I put in here actually is correct. This is not correct. I mean, the only thing that Proverif maybe can, I don't know, can be better toward, I mean, in summary, is just the efficiency and not regarding the precision.
that's what I mean. I mean, there has to be one row which should kind of show
Okay.
that it's more efficient. So I didn't mean to say that this table is wrong. I was
Yeah.
just saying
Okay.
that there is a row missing kind of. Okay,
Okay.
so I see Jonathan is in the queue, so I will stop here and let other people ask. And then I was trying to understand here minimal compromise scenarios. What does that mean? But I will come back to it later. Thanks.
Okay. You're welcome.
Yes,
Hi,
Jonathan.
hi, it's Jonathan Hoyland. I just you mentioned something very briefly, and I didn't really understand how it worked. It is gone 6 o'clock in the morning for me, so I'm a little bit slow today. How is the PSK ID bound to the PSK?
Yeah. Okay, so that's actually because I wanted to go back to this. Okay, so to be honest with you, so this is something, I mean, I was dealing with and was asking question regarding the ID Cred PSK to the designers. And what I understood is that the ID Cred PSK is just an identifier. Either it's, I mean, it is it locally binds, I mean, in the memory, the PSK on the initiator side and on the responder side, or it's actually a different ID, and which, I mean, locally different, and it should bind the PSK and the participants to the same PSK. But I believe that it should be sent or known beforehand, in the moment where the PSK is shared with the initiator and the responder. Or maybe Elsa or someone in the working group can explain this further.
So, because I remember when we were looking at Tamarin, one of the not Tamarin, sorry, at TLS, one of the
Yeah.
things that was found, one of the attacks that was found was if you end up in a misconfigured state where the initiator, sorry, thinks ID cred PSK corresponds to key 1, but the responder thinks it corresponds to key 2, they could both complete the protocol with the attacker and think it had all gone fine.
Yeah.
So
Yeah, I think to me this is something that should be specified more in the draft because, for instance, I can ask I mean, I have many questions regarding the ID PSK. For example, is the ID cred PSK, as I mentioned, locally the same for both, I mean, from the both point of views, or it's not locally the same? And also, is the ID cred PSK the same when the participants switch roles? I mean, do we have even here the same PSK or not? So I don't know. So the way we modeled this is that it is known to both participants beforehand, and it's actually the same, and it's just an identifier.
So if I was doing this, modeling this in Tamarin, I would say that I would model it as the attacker chooses, like you literally just, the attacker says to the client, use this ID cred PSK, and the responder use that cred ID PSK. because unless it's actually bound to the PSK. So like if your ID is the hash of the pre-shared key or something,
Okay.
then it's actually bound to the key. But otherwise, I'd just say let the attacker choose it.
Okay, so I think you are talking about two different things. It's the way you model it, or how it is in real life. So the way we model it is we apply only a function symbol on the PSK and the both identities cred I and cred R. So it's actually bound to bends to the both participants. But in real life, I don't really know how it should be implemented, or maybe
So
John.
So for my, like, if you want to model this, that your model is going to capture attacks that might happen in real life, you shouldn't say, oh, we assume that it's perfect. You should model it saying, we assume that it's broken, and then increase the requirements of the protocol until it fixes it.
Yes.
Yeah. Just some thoughts.
Yeah, thank you.
Yeah, just in the draft, it's not the identity. What the draft says currently is it does not force that the identity is bound to the PSK in a cryptographic way. It says that the receiver can find the PSK using the ID cred, and then it assumes that it's provisioned in a secure way. So I think any additional requirements would have to come for the formal analysis. And theoretically, you can add a lot of things. And if you have some unconstrained protocol like TLS, it's not a problem. But here, every byte counts. So like any change that would add additional bytes on the wire would have to discuss, then it becomes a trade-off.
Okay, thank you, John. So
Thank you, John.
there is Milling in the queue.
Oh, sorry to interrupt. Is still possible to change the agenda? Is it because I'm the last item? I just need 3
I'm sorry,
minutes.
we're in the middle of a slot on formal analysis. Can we take that question after the slot?
Okay.
Yeah, okay, so I'm just going to add, I put in here to add to the remark of the last, I don't know how to say his name, sorry, I forgot your name, regarding the PSK and IDCred PSK. So here, ideally, we should have a model of stateful protocols where we have really, a table and a database where we can actually store the IDCred PSK and the PSK, etc., and give the attacker the possibility to choose the IDCred PSK. Yeah, just some thoughts. Thank you.
Okay, so we have one more person in the queue. I will lock the queue after because we are out of time. Usama, do you want to go ahead?
Yeah, maybe very quick one. So coming back on this minimal compromise scenarios, maybe you can give one example of how did you find these minimal ones? Because adding these odds, it seems to me that there are multiple combinations possible. So maybe you can give a quick example of PRK secrecy upon agreement. How did you find that, or how do you claim that to be the minimal, and what was your kind of strategy in finding that minimal? Thanks.
Yeah, okay. So to me, because, how we found it, so we can start first. We just an attacker who is just active, so without compromise scenarios, and then we start by one, PSK alone, X alone, Y alone, PRK alone, right? And then if we find an attack, then we validate it. For example, here we found that it's not the property is not verified with PRK, so we put PRK at the moment here, and then we start to look at the combination of twos, right? For instance, PSK and X, or PSK and Y, and etc. And if something, a combination is actually validated, then we move to the others until we have no other combinations. and that's how we can find the minimal. And here, actually, it's if and only if. I mean, secrecy upon agreement, if and only if we have this combination. That's what minimal means.
Okay, thank you, Dekra. So the time is over. So
You're
I
welcome.
would
Thank you.
thank you for presenting. So what I hear is some additional clarifications that might be needed for the draft. So I would kindly ask the draft authors to work with this formal analysis team that responded to the analysis in order to clarify the ID cred PSK considerations in the draft.
Thank you so much, Manisha.
Thank you, Dekra, for presenting, and thank you for responding to this call for formal analysis.
Hello, can you hear me?
Yes, we hear you, Elsa.
Okay. So I'll try to be fast since we're a bit out of time. So I will be presenting the updates on the ad hoc with pre-shared key authentication corresponding to draft version 7. Sorry. Yeah, the status of the presentation. We did some corrections on the test vectors after the latest updates on the draft. We also update the security properties after the formal analysis that was just presented. And we're working on the integration of ad hoc PSK into the Lakers Rust implementation of ad hoc. So regarding the test vectors, little recap. After the last IETF, there were some changes regarding PRK for E3M, TH transcript hash 4, and the external A18 ciphertext 3B. And those changes included the addition of the PSK or the cred I and cred R in these computations. These were not included into the computation of the test vectors. So we did a new run of interoperability test using 2 implementations, one in Rust and one in C. And the test vectors were verified and updated in the draft. Regarding the updates after formal analysis, so as Dekra mentioned, there were some properties that were not verified in terms of the identity protection. And so in fact, in the security properties, we updated a possible attack regarding the unlinkability of the initiator. So the assumption is that we have an active attacker, which is a man in the middle between the initiator and the responder. So when the initiator sends message 3, which contains the encrypted identity of ID cred PSK, the attacker is going to intercept and modify this ciphertext to modify the ID cred PSK to one of his choices. This modified message 3 is going to be forwarded to the responder, and the responder is going to attempt to decrypt and verify the message. Now, because the ciphertext is modified, the EID verification will fail. However, depending on the behavior of the responder, the observable behavior of the responder, the attacker may obtain some information. So, for example, if there are different error types, whether it is an unknown credential versus an authentication failure, or timing differences during the credential lookup. And this allows the attacker to test candidate identities and observe how the responder fails. So this is very related with how the protocol is implemented. Then I also mentioned that we're working on the integration of ad hoc PSK into Lakers implementation of ad hoc in Rust. And as for next steps, well, after the presentation of formal analysis, I believe we need to clarify the ID cred PSK thing. And then I believe we might be ready to call for last call. But yeah, so that's all for me. Thank you.
Okay, thank you, Elsa. So I will wait for the green light from the author team on the working group last call. When I have that, we can start. When we have the new version of the draft, we can start the working group last call.
Yeah. Okay.
Okay, thank you. So the next item in the agenda is okay. So just.
Also, Elsa, I'm trying to give Elsa. I changed the deck. I'm giving you the. I think you have a.
So we are doing a little context switch. So let me introduce this. So we are, this is a work on remote attestation that is happening. Elsa performed a formal analysis on this draft, even though it wasn't formally called in the working group, and requested for a slot to present this. And we have additional presentation by Usama on the formal analysis after this, as well as followed by Yushuan's updates to the draft as the result of formal analysis. As a reminder, this is draft IETF Lake Array on remote attestation. Usama, yes, do you want to comment something quickly?
Yeah, so very quick comment. So I would like to request the chair, since there is already two parallel works on formal analysis going on, it helps us as researchers if you launch an official call. For example, in the paper, we can cite that, hey, there was a call, although we are already past that. So we would like to request the chairs if they can have an official call, since both are already working on it. Thanks.
Are you requesting the draft to be frozen or just the call on the list? Because typically the work.
No, not frozen. So just a request for, like, officially that the call for formal analysis is required. That would be great help for us to justify this work, and not by any means on frozen.
Okay, that's okay. Sounds good. Sounds good. We can do that.
Should I go? Okay, so me again, I will be presenting the formal analysis of IETF Lake Remote Attestation version 3 using SAPIC Plus. So I'll lay out the presentation. I will be presenting a little summary recap of what remote attestation over ad hoc is. And in particular, I'll be focusing on the studied models, which include the background check model, the passport model, and mutual attestation. I will then describe the claim security properties, which we divided in three categories: remote attestation properties, ad hoc properties, and combined properties. I will then define the symbolic analysis model that we used, and in particular the verification framework, SAPIC Plus, and how we modeled the properties. And I will end up with the results that we found and the mitigations to these results. So the models that we studied, in the draft, there are two versions, two models described, which is the background check and the passport model. So we will be focusing on what we called unilateral attestation case 1 and 4, so those that are in green, in which in the background check model, we have the initiator acting as a tester and the responder as the relaying party. And in the passport model, the roles are inverted. So we have the responder acting as a tester and the initiator as a relaying party. We also studied mutual attestation, in which we have basically unilateral case 1 and 4 combined, so that both initiator and responder undergo attestation. So as for the case unilateral attestation case 1, this corresponds to the background check model, in which we have the initiator, so the IoT device working as an attester. Then we have the network service acting as a relaying party, and then a trusted web server that is the verifier. The ad hoc session, therefore, is established between the attester and the relaying party, and we see that the attestation information in ad hoc is going to be carried on the external authorization data, so the EAD items. Then as for the unilateral case 4, this corresponds to the passport model. And in this case, we have now the attester is the responder and the relaying party is the initiator, so the IoT device. And we see that in this passport model, we actually need a fourth message, an ad hoc fourth message, to transport the attestation result in the EAD 4. And then for mutual attestation, as I mentioned, so in this case, both the IoT device and the network service undergo attestation. So the network service attestation is going to employ the passport model, so what we call the unilateral case 4, and the IoT device attestation is going to employ the background check model, so the unilateral attestation case number 1. And similarly, we have the ad hoc session established between the attester and the relaying party. So for the claimed properties, we based our definition and division of claimed properties on Usama's paper that I cite below. So we divided them in 3 groups, the first one being the remote attestation properties. And we can highlight 4 properties here, which are freshness of both the evidence and the attestation result, and integrity, similarly, of the evidence and the attestation result. So the freshness is going to ensure that the evidence or the attestation result reflect the current state of the attester or the relying party, therefore avoiding replayed or outdated values. And this can be achieved by means of nonce, a random nonce. As for the integrity of the evidence and the attestation result, it's going to ensure that the evidence or the attestation result have not been altered in an authorized manner, and this can be achieved by using a signature with the corresponding private key. Then the other party can verify using the corresponding public key. As for the ad hoc properties, we have the mutual attestation, which is going to ensure that both parties verify each other's identity, preventing, therefore, impersonation and man-in-the-middle attacks. And then we have what it's called combined properties, which mix authentication and attestation. So we have the channel binding, which is going to ensure that the attestation is cryptographically bound to the authentication. And we also have agreement of parameters, which is going to ensure that the responder's view of attestation and authentication parameters at the end of the protocol matches those of the initiator's point of view. So this property is going to ensure both authentication and attestation correctness. As for the formal verification, we did this under a symbolic analysis model. This has already been presented by TechPrep before, so I'll be brief. So we have the DY attacker that has full control over of the communication, and the most important thing is that we have the perfect cryptography assumption in which the cryptographic primitives are not breakable. Therefore, the security failures must arise from the protocol design and not from breaking cryptography. And then we have the security properties that are going to be formally expressed as reachability or equivalences. As for SAPIC Plus, as Dekra mentioned, this framework allows us to use multiple, one input for multiple verifiers. And we defined a more advanced threat model to increase the capabilities of the attacker. And in this case, we included the compromise of the long-term keys, the leakage, which is the leakage of ephemeral keys, leakage of session key, and the leakage of attestation key. Regarding the modeling of the properties, so here are some snippets of how we model the properties for the mutual attestation case. So regarding the freshness, for the freshness of the evidence, and well, the result would be in a similar way. This is captured by requiring that if we have 2 verification events referring to the same honest ones, then this must correspond to the same protocol execution. As for the integrity, we express this as a correspondence property. Therefore, successful verification will, by the responder, implies that this attestation was generated by the initiator with the same parameters. Otherwise, there was a compromise scenario. Then we have the combined properties, which are the channel binding and agreement of parameters. So for the channel binding, we state that successful attestation acceptance by the responder. So if the event attestation accept R happened, then this means that there was a previous event. It was previously sent by an initiator authenticated in that ad hoc session, unless a compromise event occurred. And for the agreement of parameters, this property will ensure that whenever a party finishes, which we see with the finish R, then there exists a unique peer execution that agrees on the same authentication and attestation parameters. Therefore, finish I with the same parameters as the previous event, unless there was a compromise event. So the results well, these are the minimal compromise scenarios again. So for the evidence freshness and attestation result freshness, the results were verified. So the nonce is indeed going to guarantee that we have freshness in both. As for the integrity, we see that the compromise scenarios include the leakage of the attestation key and the long-term key, whereas is the PSK or the static Diffie-Hellman key. We see that channel binding was not verified, and agreement of parameters, similarly, those were the minimal compromise scenarios. So what we saw regarding channel binding, in fact, we verified the properties in all 4 authentication methods, so the standard 0 to 3 authentication methods that are defined in the RFC, plus the 4th authentication method that is being standardized in PSK. And we see that channel binding did not hold. And this is because we found an attack due to the lack of cryptographic binding between the attestation evidence and the authentication session. And in fact, this attack can happen without the leakage of the attestation key. So the description of the attack is as follows. If there was a compromise of the authentication keys, then we can have a man in the middle that establishes sessions with both endpoints and is going to obtain a valid attestation evidence from an honest attester. So the attacker will present the evidence within a different session as if it were produced by that for that authentication channel. And if the evidence is not somehow bound to the session, then the verification is going to succeed. So what we proposed as a fix or as a mitigation was to include the hash of the first 2 messages in the digitally signed attestation evidence. And this is because the hash contains information that is linked to the authentication session, including the ephemeral shared secret of that session that is unique to the session. Therefore, we are sure that an attacker cannot replay evidences from different sessions. And as for next steps, it would be interesting to, because we only checked the case 1 and 4, but maybe it would be interesting to have formal verification of the other cases. So with the roles inverted for each of the models. And that's it. Thank you.
Thank you, Elsa. So we have Jonathan in the queue and then Dekra.
Hi, Jonathan again. Could you possibly go back to slide 17?
Yeah.
Yeah, I'm surprised that channel binding would work, because usually you would want to also have the hash of some secret for the channel binding to be correct.
But so when we include the hash, in fact, the hash, as I said, contains this ephemeral shared secret. So, and this shared secret, it's unique to the session. So by including the hash, we are implicitly including the shared secret as well, which is going to bind it to the session.
Is that correct? Do you send the ephemeral shared secrets on the wire? No, you just send the key shares, right?
Sorry, can you repeat that again?
So if let's say the client sends G to the X and the server sends G to the Y, you haven't actually included G to the XY in your channel binding.
No, sorry. You're right. It's the ephemeral. So it's the transcript has 2, for instance, contains the GY. So we would be including this this public key into the hash.
Mm-hmm.
And therefore,
interesting. I'd have to look at exactly how it's written, but I would be very surprised if that works without including some shared secret into the hash derivation. Yeah, I'll have to read the draft.
Okay.
Hello, Elsa. Can you please go again to the freshness lemma? the way you formulated freshness?
Yeah. Yeah.
Okay, so is it? I mean, do you here you don't have conditions regarding the PKI and PKR, so they should be different or they should be the same? I don't understand.
So here we are saying that if we were to have, they could be different, they could be the same, but if the nonce is in fact the same, that this means that these events must actually be the same, because we cannot have a nonce that is repeated amongst different sessions because it's freshly generated.
Yeah, but if they need to be the same, okay, so yeah, because you know some of this, I mean, security properties are not conventional security properties, so that's why I was curious on how you formulate them. Okay, I will have to look at this again. Thank you.
Okay.
Yeah, so following up on what I understood from Jonathan, I think there is one thing more missing, which is that the identity of the endpoints itself is not yet established at the time you generate that evidence. That's my core concern, but I will talk about it in my talk. So I just wanted to know how that property that you have, if you go back to the channel binding property that you state.
Yeah.
So I'm a
Sorry,
bit
to the,
curious about,
oh,
so the one where you show that was fixed. So I'm very
ah,
skeptical about that being fixed because of the reason that the time at which you generate that evidence, it's not yet authenticated. So I will talk about it in my talk as well. So I just wanted to raise this issue.
okay.
Okay, we had to lock the queue at this point because we have a packed agenda. We are over time, but thank you everyone for your comments. It is great to see that these models are open source and published. And I would invite all the interested folks to look at the models and to provide feedback to the working group concretely on the properties, how they were defined and the models as they were defined. So, Sama, you have 5 minutes. I believe this refers to the same version of the draft, Lake Array 03. So you
Yes,
have
that's
5
correct.
minutes. Yes.
Okay, thanks very much. Yeah, this is joint work with Vyacheslav and Jan Meri, and thanks to Yukshuan, Marco, and Goran who helped us in this work. And specifically, I want to describe the motivation why we already started even before the call for formal analysis was there. Our brand new charter basically says that we will borrow as far as possible from RATS and TLS working group. And this work was basically religiously following the draft of Sati TLS attestation to which I have been contributing. And formal analysis as per charter was welcome, not specifically for this draft, as I said, the call, but overall it is welcome. So we already started the work since we had done the work for attested TLS. So we believe that it's a subtle addition. It does need formal analysis since we have found many attacks in formal analysis of attested TLS. That's why we started already. And the kind of the thing is that from attested TLS, what we have noticed is that the devil is in the details, as the kind of a clumsy picture here. So I have three levels, which is the one at 1B, level 1, level 2, and level 3, which is level 1 is the shared GXY. Level 2 is the handshake traffic secret of the client. And I'm taking from the client perspective. It can be also from the server perspective because here the server is the tester. So client is the one who's going to send the secret. And level 3 at the bottom 2D is the application traffic secret of the client. And I want to make specifically two arguments here. Number one is that what Ecker actually raised at the time of the chartering of the seat working group. And he said that, hey, look, this handshake traffic secret is independent of the security claim. It's irrelevant. And we checked that we removed all of this encryption, which you see in the brown color, KSH and KCH. These are the keys derived from the handshake traffic secret of the client and used for encryption of these messages. So removing this encryption makes no difference on the security properties. It's important for privacy, not for security. Second argument here is that HTSE, which is handshake traffic secret of the client, is derived at the point in time where number two of authentication has not even started. So if we generate that evidence which is to be put into the certificate message in TLS, we don't actually get that guarantee. And moving on to from attested TLS to attested ad hoc, what we did was the approach overall, as I posted in the one of the threads, was we used modularity. That is to say, both from model and the properties perspective. Properties already was presented in one of the talks. So from the protocol perspective, what we did was this is the key exchange part, the first part, and then the authentication part that remains the same. We applied some abstractions, which we don't currently have a proof that they are completely sound, but that looks reasonable to us at the symbolic level, and that's what we use currently. We are refining it further, and we will also share the paper that we have ongoing on that. And analogies basically here mean that which key represents which key from TLS represents which key in ad hoc. So that's the kind of analogies that we did here. And based on that, what we have is the results for correlation properties, which we presented in UFMRG in last meeting, apply as is to this protocol version 3. There is no binding, as Elsa already pointed out. So there is no binding from the evidence to that specific connection which is established. And with that root cause, all of the three bindings, that is to the GXY, the shared secrets, handshake traffic secret, and the application traffic secret corresponding to the TLS properties still apply in this case. And the proposed fix specifically for this is to use post-handshake attestation because of the server authentication not being there, and in this case, the responder one not being there. So that's pretty much it. I see Yukshuan in the queue. Yes, please.
Okay, hi, I'm Yuxuan. So after your slide was uploaded, I have sent them email in the working group to ask like if you have any links that can provide to tell us like how you got these results for the derived attested ad hoc, because from all your public results, I think these are all for the results for the formal analysis of attested TLS, and I agree that attested ad hoc somehow follows the attested TLS in the attestation part, but still they are two different drafts. So and also from your reply, I didn't see that you provide the links for the model that you have for the draft attested ad hoc. So I do not agree that here in the table of the results you put the draft lake RA here, because you, at least from we know, you do not have a real model that is only for attested ad hoc, and I don't think it's correct to just copy the results for attested TLS and then put it here in the table for the attested ad hoc. So yeah, that's my that's what I think.
Okay, so I want to recall you that we had a meeting between you, Elsa, and the Militia in December 22, around of that time. So we had a long discussion about that where I explained you all these attacks. And you're right, we don't have the model as Elsa has. We have modularity and analogies and abstractions, which I explained, and we will make that all public once we have that paper accepted. So I will explain you again how all that works, but I completely disagree with you that the attacks do not apply. There might be soundness reasoning that, hey, this doesn't, the abstraction is not sound, that's fine, but the attacks do apply, and I can share with you the attack traces. That's something I can share with you.
Yeah, and actually the reason I ask this question is because I completely understand what you explained to me, because what you explained to me is the attacks that you found in attested TLS. And as you said, Elsa also had the formal analysis because and she also shared the public source code for the formal analysis. And here I think you are just copy the results you have for the attested TLS. So I don't think it makes sense.
Yeah, it might not make sense to you. It makes perfect sense to me because it's just following the same protocol and the same analogy. So you might disagree,
Okay,
but the
so may I
attack
interrupt?
traces are.
So TLS and
Yeah,
ad hoc are two different protocols with two different key schedules. So it would be useful to the working group, I agree, to have the models published. So as soon as you have the paper, the publication pending or whatever published, it would
yeah,
be good to send this to the working group so that we can examine closely.
sure. Yeah, I already pointed out that we will share it and that will be under Apache 2 license so everybody can have a look and satisfy themselves. And
Okay.
I believe that this feedback is already sufficient for the editor to move forward.
Okay. Thank you, Sama. Thank you for doing this work. So we have Zhang in the queue.
So I have the comments of your proposed the fix is Junjiang from Huawei. So security is important, but the security is not everything. So this morning, everyone have noticed that there's a crash of the internet connection, right? Everything is cut off. This is because if you have very serious, important consideration of the security, you do not have a good usability. So in this case, for the attest ad hoc, sometimes we need a very small delays so that if you have the post handshake, you will violate the requirement of the application in the attest ad hoc. So I have some draft submit to the seed, but due to the time delay, I have not successful submit, but I will share my consideration in the seed working group, and so welcome for the feedback. Thank you.
So your concern is about attested TLS or attested ad hoc? Which one, June?
For the general case, so that the security is not everything. You need to consider the trade-off. Yeah.
That's fine to have both solutions. I mean, I'm not advocating to have post handshake only if you want. So if there is some genuine concern that you have or a genuine case, I would really love to have a look at the use case that you are mentioning, if that's worth it, that we still live with the attacks which are possible. Thanks.
Thank you. Moving on.
Okay, thank you. Yes, we need to move on. So the next slot is the draft IETF Lake Array 04 presented by Yushon. So this will present, in my understanding, the updates to the draft as they have been done after following Elsa's presentation.
Yeah. So hi, I'm Yuxuan, and this is for the update for the draft remote attestation over ad hoc. Next slide, please.
Have the slide clicker normally.
Oh, okay. I don't think it works.
Now you have it again. Yes.
Yeah. Okay, good. Okay, so a quick recap is that this draft specifies how to perform the attestation by using the ad hoc EAD fields, and the figure here is an example for the mutual attestation, which is defined in the draft. So for the updates we have, the first one is based on the formal verification results from Elsa, who just presented. So the results show the attestation evidence is not bound to the authentication session. So when the authentication key leaks, it may have a potential relay attack that the attester, the party who generates the evidence, is not guaranteed to be the initiator who authenticates. So the figure here is also like quite similar to what Elsa had in her slide. So when the attacker can impersonate, when he can impersonate the ad hoc roles and has two different sessions, then the evidence that is generated in session A by the initiator A will be received by the attacker and then be relayed to the session B. And since the evidence is not bound to the authentication session, so here the evidence which is generated in the session A will also be accepted by the session B, by the responder B. So this is something that we found the channel binding does not hold in the version 3 in our draft. So then we have the mitigation as an attestation binder. So this was added in the current version, and also like followed by the suggestion from the verification results from Elsa. So when we have the attester as initiator, we have the evidence that is sent in EAD3, which is in ad hoc message 3. And here we have the attestation binder, which is defined as the hash of the first two messages. And the hash algorithm is the selected cipher seal that in ad hoc. And then because of the implementation considerations and also to be aligned with the draft lake oath, we decided to change in the next version to let the attestation binder be the hash of message 1, comma, message 2. And also this attestation binder must be included in the evidence and then signed by the attestation key. So as you see here, when we have the evidence that contains the attestation binder, which is the hash of the first two messages, and this hash of the first two messages is somehow session unique. So in this way, we can say like the evidence is cryptographically bound to the authentication session. So when the responder receives this evidence, he will check if the attestation binder is the correct one, because the responder itself will also generate the attestation binder by calculating the hash value. So if it's the same, then it's correct. Otherwise, it will not continue the following operation. And then we also have the case that the attester is the responder. So this happens when evidence is sent in message 4 in EAD4. So as in ad hoc, we know that after 3 messages, we have the final session key derived. So here we define the attestation binder that is derived by the ad hoc exporter. So if you know ad hoc, you will know that ad hoc exporter is derived by the final session key. So in this way, we can bind the evidence with the authentication session. And of course, the same, this attestation binder must be included in the evidence and signed by the attestation key. And then for the next issue, which I remember was raised by Carson, we this time fixed the CDDL syntax errors throughout the draft. And I think which was also mentioned by Carson, that we are thinking if it's possible to validate the CDDL syntax as part of the continuous integration. I don't know if Carson is here today, but if he's still willing to help or give any guidance, it will be very appreciated. And then we have some issues for the clarifications and editorials. So we explain the difference between the background check model and the password model. And then we add rights part in the privacy consideration as well. And then we added the requirement of the ability to generate random nonce, because when the reliant party is the one who needs to generate the nonce to guarantee the freshness of the attestation result, we need to make sure that this reliant party, when it's a constrained device, has the ability to generate a real random nonce. Okay, that's it. Thank you.
Thank you, Sean. So we have 2 people in the queue, Usama and Zhang. So Usama, you want to go?
Yeah. So I will put your question back to you. So why do you think that the attacks do not apply in your specific case? And I want to follow up also on Manisha's point specifically here. So at the symbolic level, if we talk about the symbolic security analysis, basically if you see that the functions are assumed to be ideal, so that doesn't matter whether it's TLS key schedule or it's ad hoc key schedule, that's how the proof is derived. But I want you to explain me, why do you believe that, number one, the hashes that you have used are sufficient? And number two, why do you believe that the attacks are not possible?
So I will cut it here, Usama, please. There is a point of disagreement in the group on this. So I think we all agree on that. One group has published their models. You have not, and you have not provided the attack traces. As soon as you do that, we will be able to discuss in details this matter further. So I would postpone this discussion to that point once you can publish the models. Thank you.
Yeah, and also I've sent you, Usama, I will send you the email to say that we can have the meeting, but I didn't receive the response. So if you are available, we can also have a meeting to discuss this deeper.
Let's please take that offline. So we have another comment.
So just 2 comments. So for your operation of you will take the hash of the message 1. So what do you think that if you use the XOR instead, it will be better, or it's another alternative for that message 1 with XOR certain value? So for a lightweight operation. So this is the first comments. And for the second one is that, so you see that in sometimes with the relay party generated nouns, so when it is do not have the ability to generate a very strong random number, you can look at the recent epoch marker one, so that epoch marker will generate a strong epoch ID, so that you can have the concatenate of the random number generated by the relay with the one from the epoch marker, so that will generate a stronger random number. So you can have a look at
Okay.
that.
Okay, thank you. Yeah.
Yeah, I'm just confused by the discussion. Seems like Osama claims that the TLS attacks apply to 03 and probably also the 04, and then Elsa has formally verified 04. Okay, yeah. It seems, I don't know. It seems to be. It seems like I have not read any of this, but it seems like some simple misunderstanding. Probably an offline meeting would solve that.
Agreed.
Yeah.
Agreed. So yeah, I would propose to the authors and the involved parties to have an offline meeting, and then to feed back to the working group based on the discussions during that meeting.
Thank you, John. Okay. Thank you, Shushan.
Sean, yeah. So with that, we can move on. The next item in the agenda is draft IETF Lake odds, presented by Joanne.
All right. Yes, works. Thank you. All right, so Jovan here, and I'm presenting updates on version 07 of lightweight authorization using NetHawks. So, big reorganization of the draft. We found a vulnerability where the device, the initiator, you, can be impersonated to W. So to give context, so you can ask for a voucher via a domain authenticator V, and which will forward this request to W, and which will, upon authorizing this request, reply with a voucher, which is then sent back to the device U. Yes, and this voucher, it can mean binary decision, authorized or not authorized, or it can contain some opaque information detailing what kind of capabilities the device is allowed to do in the network. For example, to trust more or less, or do different capabilities related to the network that it's joining, or the type of domain it's enrolling. So this is the context. And then what we found is that if, for example, if impersonate is you when doing this request to W, then W will still issue a valid voucher for you. So what happens is, if Eve learns the IDU, the identity information of the device, which is not secret, from a legitimate U, it can construct a valid voucher info which contains that identity information and will be read by W. And if that is in the authorization policies, then W will generate a valid voucher, which is sent back to Eve, and then Eve can decrypt that voucher, and so it can learn whether or not U is authorized. Even after Eve can just not continue with the protocol and give up, or if it continues, then V will realize that Eve does not have the right cred U transmitted in message 3, and then the protocol will fail. But at that point, Eve already learned something about. So that's the consequence. So that there is an information leak where Eve learns what you can do in the system. So as I said, in the more simple case is a binary authorized or not authorized information leak. In the most complicated case, Eve can keep learning about what devices can do in the network. So then, yeah, this slide is just what I just explained. If there is no opaque info, it's a binary yes, no. If there is opaque info, there is more information. And so the solution is actually a major protocol update. So where we moved the request, which was before it was happening to use the EAD fields from ad hoc message 1 and 2, we moved it to message 3 and 4. Because with that, we give the chance to V to first check if the device, the initiator, it's actually, if it actually contains a valid credential before doing the authorization. And this actually aligns with doing first authentication and then after doing authorization. And before we are authorizing something, before checking the real identity of the device. So that's the overview. And now I'll go into the details of several changes that were done as a consequence of this change. So one of them is that because now we start the protocol in message 3 instead of starting it in message 1. So then we don't use an additional identity for you anymore because message 3 already carries ID cred I. So we just rely on that ID cred I, and then we forward it to the V will forward ID cred I to W on the voucher request. So that means that the voucher info, which is carried in message 3, also does not carry IDU because that would be redundant. This has an implication that because normally ID cred I is supposed to be understood only between U and V, but in this particular case, ID cred I must also be understood by W. So we have a restriction on the namespace of ID cred I such that it should be unambiguous also to W, which makes sense because this is a use case, a very particular use case where W is also involved. The second implication is that we modified the external AAD of generating the voucher because before we were binding it to the session using the hash of the handshake and the credential of VIP, and now we don't have the identity of you in the hash of a handshake anymore. So we actually decouple it. So we have the hash of message 2 and 1, ID cred I and cred V to bind to the ad hoc session, also to you and to V. And this also has the advantage of working, the same structure works for both the forward flow and the reverse flow of the draft. And another implication is that in this new protocol approach, the two runtime join with, in conjunction with constrained join protocol is no longer applicable because we don't have really a way to carry the last message together with message 4. So then we removed that appendix. Some other changes still part of this PR of this update, where is that now V can be more flexible on when it can ask for, when it can decide to fetch or actually verify the credential of you. So we leave to V the decision of whether to process the EAD field 3 of Lake Alts as a pre-verification EAD item or a post-verification EAD item. And this aligns with the implementation consideration drafts. So in case V wants to do consider the EAD field as a post-verification EAD item, it can also try to rely on W to obtain a credential, the credential of U. So then it can indicate to W using the field fetch cred U that it wants to obtain the credential of U. And W, if it has this credential, it will return on the voucher response. We have been questioned why W is not always sending it back. And the reason is that the responsibility of fetching cred U is on V, and W may help if it's available, but it's not the responsibility of W. So that's why the returning of cred U is optional. And with this, in the same PR, we also made EAD for optional. So this was discussed in a previous version of the document, But then we got a comment by Christian, and so we make the whole EAD4 optional instead of only the voucher. So this also makes processing the protocol more clean. This change also makes the protocol now compatible with Lake ad hoc application profiles, so that message 1 and message 2 are now free to be used to advertise LS support, so that you and V can advertise that they implement this protocol. And this was a subject of discussion in previous versions. So now this is one clear solution, and we added an example in Appendix 8.1. We also addressed the issue of support ad hoc with post-quantum security cipher suites. So we added an extra field called ephemeral keys _ ciphertext. So depending on the ad hoc key exchange algorithm that is selected on the cipher suite, then this field will mean a Diffie-Hellman public key or a CAM encapsulation key. We had an open issue of allowing for the keys of V and W to be the same, but this was the main use case was to perform a sort of encrypted client hello. But since now we are moving to message 3 to start the protocol, so that use case is not applicable, so we close the issue. Finally, we have an open PR with a discussion about clarifying that fetch cred U is best effort. And in which cases, if V fails to obtain the credential, the session is aborted. And a recent PR developed during the hackathon here at this IETF 125 with a review by Marco. So thank you, Marco. Several clarifications on the use together with Lake application profiles, not reusing the ephemeral key of ad hoc in the new version, and determining we also discussed that it makes sense that V always use the same credential with U and W because there is a particular use case, a situation if V uses more than one credential, we want that the credential used with U is the same that is used with W. That simplifies when W needs to compute the voucher, which credential to use to do the binding with the identity of V. We updated the interoperability section where we defined that V must support both flows so that we can have a default interoperable case. Some adjustments on the REST error codes and some editorial fixes. So this was a very good review. And also we also synced with Lake remote attestation to rename and adjust the order of the fields so that we define the ad hoc session binding that is used in generating the voucher to use the same order of fields. So we have the hash of message 1 and message 2. This is also good for the implementation because on the message 1 we already save the hash of message 1 after processing it because we need it after. And next steps, first of course is resolving the last open PRs, but we believe that the document is solved several of the points that were open, and hopefully it's ready for open working group last call.
Thank you, Giovanni. So Christian has a comment.
Yeah, thanks for all that work. I think that moving everything down from messages 1, 2 to messages 3, 4 is premature because I think that there are better mitigations for the leaked information for the attack that you found. I'm working on writing that all up. We've already been discussing, so I really appreciate that we could, with the older version, do code JP much better, and that a lot of the exchange can be done with really small and short messages. And I hope that we can preserve this without moving everything down a message.
Okay, so I believe we can have a discussion internally about this, but one of the questions is that when we did this modification, we also simplified a lot the protocol. So we rely less on specific new cryptographic elements. So it's also more, in a way, more cryptographically safe. It's a more thin layer on top of ad hoc to what we can achieve.
Okay, so we have Zhang.
Can you go back to the slides that when you mentioned that in this version you have go back to use the ID credit I. Yes, go back credit U. So I'm saying,
is this one or no?
Maybe two slides before. Yes, I did both in this one. So yes, just one slide after. I'm thinking that whether there's a problem of the privacy. So in your case, do you need to consider the privacy or not? Depends on use cases.
Yes. So in the previous version of the draft, we were protecting the identity of the device,
yeah,
but at the cost of doing authorization without checking, without really authenticating the device.
Yeah.
So that's the trade-off we did.
Yeah. So it depends. That's you can have a look at it to see that whether you need to have some way to protect privacy or not.
Correct.
Okay. Thank you.
Thank you.
Thank you, Joanne. So what I hear is that Christian would like to discuss this a little bit further. So I propose that we have an off-list meeting between you guys, and then that you come back to the working group with the conclusion of that meeting, whether we can proceed as is merged now, I understand, or we revert back to the old flow. Okay, so we are quite a bit over time. So Marco, if you could trim off some minutes on your two presentations, that would be highly appreciated to give speakers at the end of the agenda opportunity to present.
I'll try. Thanks. Hi, everyone. This is an update on the implementation consideration draft. Next slide, please.
You have control, Marco, I think.
Oh, thank you, of course. Yeah, this has been always about providing consideration for implementers of ADOC to not reinvent the wheel or rethink about old-fashioned problems. It's the same set of topics covered almost from the beginning of this document as a working group document. And other than touching on these points, in general, two other documents have been considered as case in point beyond the basic ADOC protocol, meaning the ADOC and OSCAR profile base in this working group, and the ELA document that Giovanna has just presented. So since 2 versions ago, actually, other than editorial improvements, most of the updates have been related to the work that was going on ELA that Giovanna presented. That inspired, first of all, some additional general contents, of which ELA is a particular example. If one of the ADOC peers learn a new credential on the fly and that credential is valid, it might be that in some cases that credential has to be treated during the ADOC session just as provisionally trusted, because some confirmation of that has to come later on in the execution of ADOC. For example, the voucher in ELA. So that was discussed in general terms as a concept in section 3, and then in the particular ELA-related section 332. And then in general, again, on the processing of an incoming message with particular reference to message 2 and 3 as those where the credentials come. So if anything is going to change again in the ELA document, I think the general concept is still good to have and found out. And worst case, it's about, well, changing the ELA specific section to something else to reflect the latest version of the ELA document. And also related to ELA, when it comes to its specific session, well, here I just try to write things in the spirit of this document, aligned with the new regular flow that was updated in ELA, while the reverse one got unchanged as far as I understood. thinking from the point of view of the considerations given in this document, if a peer learns on credential on the fly, well, it really accepts it. If the learning policy is just called learning, so the very generous one, if it's no learning, it's still fine if you have compelling exceptions enabling that. And in the case of ELA, the exceptions would be, for the initiator explicitly opting in to run the ELA procedure with the expectation to request and obtain the voucher. And for the reverse message flow, it's even more explicit, the initiator who have been receiving the voucher. More updates, somehow still related to ELA again, were inspired by Christian in an open issue that was crossing this document and the ELA document, where in its previous version, in case the voucher was not issued, there was the ED item included, but with no value. ELA changed that. I'm happy to see that also. Well, in that case, the ED item is not included altogether, which is better actually. And that trigger talked about the implementation of an ad hoc peer as a peer receiving an incoming message is supposed to be absolutely able to detect the absence of any AD item, especially if it's an expected one that was kind of requested for, like in ELA, again, expecting a requested voucher. So in this document, taking again ELA as a case in point and a relevant example, there's also general discussion about this expectation on implementations. They have to be able to track expected EAD items and to detect their absence. And if something really expected is absent, well, that may be a reason, depending on the procedure in question, to terminate the session. It's becoming more and more expected. In the near future, it will be formally expected, I believe, to include operational considerations in document according to an OPSA working group draft right now. I tried here. I believe this draft doesn't really have anything special to say from that side. And if so, well, you are still supposed to include the section with a well-known boilerplate, just giving a reason why. And that's literally what you find in the very short section I added on this topic in the document. I believe at least that to be the case. So I believe everything I could think about was put out here, and I could benefit of somehow other people's experience, mostly Christian and Giovanni, largely related to ELA, and also covering the other ACE document, taking another angle. This is just, again, a summary of this update. I believe this should be ready for working group call now.
Okay, great news, Marco. Thank you. So let's write this draft in the queue for working group last calls to launch after this meeting. So I believe the first one is Greece that we agreed on, and the second one is this draft. And with that, I guess we can proceed to the next presentation.
Give me 1 second. I have to take control back. You are good to go, Marco.
Thank you. This is an update on the other draft on the app profiles. And to recap, this document started to provide a number of means, or a toolbox if you want, to help ad hoc peers coordinating about what they support in terms of ad hoc features and capabilities, or so-called ad hoc application profiles. This can be expressed in 2 different flavors: a la carte, just spelling out the features, or as a compact menu, meaning the profile identified by an integer abbreviation. And there are different ways or venues where you can express these preferences or advertised supports. They have been quite stable for a while now. They are during the ad hoc session in itself, or out of it, typically in advance. Yeah, since the previous version, other than editorial touches, there was a little clarification to give that was identified during the presentation in Vancouver in November. Peers have to be vigilant that if they learn about something prescriptive, that it really has to happen during another section, and then there's a violation about that by the other peer. That evaluation does have to happen upon receiving a message, but not only, it has to continue throughout the execution of the session, of course. Otherwise, the session has to be aborted. It was just about those 4 red words to add. Yeah, I revised the CDL grammar. There was a mistake in one grammar, now fixed. I defined the CDL grammar for two of the parameters defined in this document in the same namespace, otherwise mainly defined in the ACE document, creating the overall data structure and registry. After submission, I just noticed a typo in the bottom right grammar there. It's correct in the slide. It's wrong in the draft. I'll fix that in the next revision. It should really say exported outline like in the slide. Yeah, I also consider issues from Christian, especially number one. Thank you. It was basically an invite to revisit the set of parameters that were floating around as if really necessary or instead possible to remove. Yes, 4 were definitely possible to remove, considering the experience we now have more about EDO compared to the time of the standardization. The actual removal of the parameter definition happened in the document where they went defined, the ACE document. In this document, of course, we removed their use or discussion, and we also removed the definition of the corresponding link target attributes that could be used when using web link as an advertisement means. That also resulted in the removal of some corresponding new IANA registries that we were defining. About this, it refers to the new EAD item that we are defining in order to advertise the peers capabilities during the execution of EDOC itself. This slide refers specifically to the use of the EAD item in message 1, where the initiator can optionally include one Boolean flag at the beginning of the EAD item value. I renamed that from reply flag to advertise flag because this new name fits better for the new possible use that comes in the next slide. But this slide focuses on the original use in the EAD item. The semantics is still the same. If included, the flag can be true or false. True is an invitation to the responder to talk about itself in the following EDOC message. False means don't bother telling me. I clarify how it is possible to still use that for the initiator in case the initiator does want to ask the responder to talk about itself, but the initiator also doesn't have anything to say about itself in message 1. That is still indeed possible by setting the flag followed by essentially no information about itself. I think it was worth spelling this out. But on the new use I anticipated, that was also suggested by Christian in another issue. Thanks again. This same data point would also be useful when advertising the EDOC capabilities of a server in SVCP record, resource records return when doing DNS resolution for that server. I had to re-engineer a bit the semantic of the wire format of the SVC key related to this information about the server. The final effect is basically that the information that could be provided before now can also be optionally prepended by that Boolean flag if present has as only possible value true, and the server is indirectly saying to whatever other peer finds it through DNS discovery that, well, the other peer that has found the server is very encouraged to tell about itself to this server when running EDOC, just for the sake of disclosing its EDOC supports. Yeah, I added a lot of examples that I promised in Vancouver. One is about the use of calling format with a particular use of some target attributes related to the supported trust anchors that was missing, and I think we're doing. All other examples are in cyber diagnostic notation when using essentially the different means of advertisement. So the ED item in message 1 or 2, the EDOC error message with a new error code, and the wire format for the 2 new introduced SVC param keys when using the SVCB resource records. Yeah, I also visited finally the security considerations other than obvious inherited ones. I tried to emphasize that some approaches for this advertisement are unavoidably non-protected, for example, when relying on EAD1 in EDOC message 1, on discovering from well-known core that is not protected. If you acquire this information through an unprotected channel, you really need to bear that in mind and treat them as a hint. Worst case, an adversary may induce you to have wrong expectations of the other peer's capabilities, but this shouldn't really have any impact of the security of the other protocol in itself that eventually is performed according to what the two peers really agreed to do in the first two messages, for example, out of the cipher suite negotiation. And like mentioned in the previous presentation, since this is raising expectation, I also added a section on operational considerations. Here there was quite something to say, actually. I think that fundamentally what this draft proposes is also in the interest of operational consideration to have the network run in a smoother way, since it facilitates ad hoc peer to agree on how to run ad hoc and to discover each other's capabilities. And as long as this advertisement happens in some non-protected ways, and there are a few, like I mentioned before, operators may even take advantage of that and understand most preferred ways or most supported ways to run ad hoc, and in turn build on that information to do some fine-tuning of the network setups or to learn what are the most popular, favored, whatever ad hoc application profiles that maybe deserve more attention in terms of maintenance and implementation. And on the other end, on the peer side, I'm trying to encourage peers to remember what they have learned about other peers, just to not rediscover the same things over and over with possible additional network traffic that can be avoided. And even ad hoc session fails in spite advertised capabilities of other peers were followed by the book. Well, that should be reported, and it's possibly the starting point to detect anomalies and misbehaviors and peers to remove from the network. Yeah, I also think this draft is complete from an author team point of view in terms of content. There's no open issues or points as far as I know, and content-wise, it should also be ready for working group plus call. I just wanted to point out it has two drafts as normative references. One should be fine because it's in ISG evaluation now, so if you have a 9 certificate. The other one is the ad hoc underscore application profile. In ACE, the working group is still working on it. So even though, again, I believe this should be ready in itself for working group plus call, and maybe time-wise, that dependency can be factored in to have the working group plus call later. But I leave that consideration to chairs and AD. Thank you.
Thanks, Marco. So I would suggest we proceed with the working group last call, and then the second draft can wait on. We can wait in the ISG queue, like once the other draft aligns with us, essentially.
Fantastic. Thank you.
Yeah. So the action item, same as for the previous draft. Add this draft to the queue of working group last call items to launch after this meeting.
Thanks, Marcio.
Thank you, Marco, and thank you for being concise. So we have 18 minutes to go in the meeting, and I believe we have 3 presentations and 1 time permitting. So if everyone could shim off like a couple of minutes of their allocated time, that would be highly appreciated.
Hi. Well, I am Lidia Pocero from the Industrial System Institute, and I will present the last updates in our drafts regarding key-based authentication. Well,
Let me just interrupt you for a second. I forgot to introduce that we are now skipping to the individual drafts. So Marco's presentation concluded the adopted drafts of the working group, and we are now passing to the individual drafts, and these mostly consider quantum-resistant ad hoc methods.
Well, let me just summarize the current post-quantum supporting network. I mean that from the ad hoc RFC, they were already introducing that the use of ephemeral terms will be made it with the method 0, and also is there the draft system for the cipher suite quantum resistant that in a way complete the post-quantum signature-based ad hoc, and also the method, pressure key method, using corresponding quantum resistant ephemeral kern will also be quantum resistant. Then just tell that both approaches have some limitation because the pressure key based approach requires this pressure knowledge, and on the other way, the post-quantum based signature-based EDHOC introduce significant overhead when we are speaking about niche standardized signature schemes that have longer key size, high processing time, and high memory overhead, and that brings us to the motivation of our draft, that is it is to complete this post-quantum EDHOC portfolio with the key-based authentication method that provide signature-free authentication for one or both parties. We first address the post-quantum equivalent of method 3, where both parties use static key pairs for authentication. And starting from the version 1 of the draft, we extend this work to also support post-quantum versions of EDHOC method 1 and 2 by allowing hybrid authentication combinations. Well, in the method 4, we have this in which both parties have the signature-free authentication. An ephemeral key is used for the key exchange, and a key mechanism authentication for both the initiator and the responder are used. Unlike of the Diffie-Hellman, authentication requires now receiving an encapsulation of its static key first, which add a key confirmation step, resulting in this 5-message handshake. The method 5 provides signature-free authentication for the initiator. Then the initiator uses KEMS and MAC, and the responder uses a signature to authenticate itself. And just make the reference that in a different approach in which we would like to authenticate early, instead of put the signature in message 4, we could bring the signature to message 2, that as just the method 2 of EDHOC make it. But in a way, we will stop to have the same scheme for all the KEM-based EDHOC. When we speak about the method C, is now the responder who is only the signature free, and now the message 4 is half a MAC and message 5 have the signature. Again, this signature will come to message 3, that we will reduce the message size because we don't need the message 5 anymore. But again, the methods between them will not keep the same structure for KEM-based. And this is the key schedule that we have already speak about. We don't have time. Let's go directly to what changes come in the last version. The first one is just we identified was an issue with the ordering which we computed transcription hub of peer key, and we solved it. We then add a transport consideration section because the post-quantum KEMS and signature produce much larger methods, and methods may access the MTU limits in constrained network, and in this case, fragmentation at the transport layer may be required, and we refer mechanisms such as co-block waste transfer that can come as possible solutions. Notice that with this larger methods and fragmentation requiring acknowledgement, the key goal in the design should focus on reducing the overall handshake size rather than the number of messages. There has been some questions regarding, wait, because I think, sorry, I passed 2 times. Yes, there has been some question regarding responder identity protection against active attack. Then, because it's important to try to have the same properties, security properties as the original EDHOC, let me tell one more, that the initiator credentials are encrypted in message 3 using 8 with a key derived from the ephemeral series secret and the responder static series secret. Then only the legitimate responder who owns the corresponding private key can derive the key, decrypt the message, and retrieve the initiator credential. Then, to also prevent the initiator from revealing its identity to untrusted responders and to stay aligned with the original EDHOC, we add the requirement that the responder credential must be authenticated and validated by the application before the initiator sends its own credentials. And the last chain, wait, sorry, it's different order there. The last is that we also add a new section that is the KEM security consideration section, because prior research showed that in CCA2 security alone is not always sufficient for KEM-based key exchange protocols, because they may still be vulnerable to re-encapsulation attacks, which can lead to a no key share situation where two parties derive the same secret but associated with different identities. For this, we clarified that the KEM used in this protocol must be in CC2 secure and ensure that the read secret is cryptographically bound to the recipient's public key. These two things are guaranteed for SCEM to some MLKEM. We also are collaborating with Vaisanavi from IIT Delhi to try to formally verify the protocol. Since we have using firstly the Tamarin tool, and we are focusing the method for. And since the KEM encapsulation output both CipherSuite and secret, we introduced two functions, KEM-ENC and KEM-CSS to adopt it. We also defined the KEM card to read the public key from a secret key, and add some necessary equations in Tamarin, but just because we don't have time, just to fast tell you what we have achieved until now. That is work in progress. We have not finished, but first we have proved secrecy of the final session key, meaning that once the protocol completes, only the initiator and the responder know this key. Second, we have injecting agreement for the initiator, which ensures that if the initiator finishes on believing its communication with a specific responder, then that responder must have participated in exactly one match session with him. And also the injecting agreement for the responder. And we managed also to verify other properties and secrecy of intermediate key materials and perfect forward secrecy. And our next step is to work in this formal verify this of the identity protection of credentials, that we have to move for this to the proof verify tool, and we expect to have this finished before the next IETF meeting. Just for the last, for the second draft, just I wanted to tell little things that to notice that the goal of this is to reduce the handshake to 3 methods targeting scenarios when the initiator already knows the responder credentials. And one of the main updates is in this version 2 is we highlight the decision principle of this protocol, which follows the noise framework. In this design, its new series secret is immediately incorporated into the key schedule, improving the protection of subsequent methods. For this reason, the key schedule is adapted to incorporate all series secrets that are already available after message 1 for the responder and after message 2 for the initiator. And in this way, we prioritize maintaining the design principle of the framework rather than keeping the key schedule identical to the original headhook. There are the summary of the last change that we make it, and because we don't have a lot of time, yes, thank you a lot.
Thank you, Lydia. So we have Dekra in the queue.
Yeah, thank you for the presentation. So you said that you worked with Tamarin, right? And for the formal analysis. And as far as I know, the standard way to model KEM in Tamarin is that you use just asymmetric encryption. Did you use asymmetric encryption to model the KEM? Or is it another?
To these questions, it will be better to speak directly with the Vaisanavi, that today couldn't be here. But what the model that we use was similar to the model that they use KEM-TLS, Tom Wigger in one of their papers. And they have their model open in GitHub, and we use the same approach. But for more details, again, be free to mail Vice and Avi that is more expert in this, but today could then join us to explain it better.
Yeah, okay. So just one single remark regarding that, because the standard way is just use asymmetric encryption. So the message is the shared secret in the KEM, so that the shared secret won't be, bends the static key. So that's my only concern regarding that. So maybe you can use a library in Tamarin, which is, more sophisticated into bendings, the static keys, etc. And also just a small remark that, the binding properties that in the KEM do not just are not just specific to the static key, so that we have many binding properties, for example, for the ciphertext, etc. So maybe you should investigate this further. Thank you.
Okay, for sure. Thank you very much.
Okay, thank you. So we lock the queue. We lock the queue here. Thank you, Lydia, for presenting. And we have one more presentation on the 00 version of a new draft that was submitted by Clement. Clement, can you? So you have, let's say you have 5 minutes, because we would like to conclude the meeting at the end. Thank you.
Okay. Do you hear me well? Okay. So hello. So I'm Clément Papon, a PhD student at IXLIM in Limoges in France. I'm working on cryptography. So today I would like to present you some proposal for post-quantum secure extension for EDOC. So there's 5 protocol proposal. I will just review 2 of them today. So the first one is a variant of what Lydia proposed. When the initiator already know the responder, I will try to propose a flexible way where the initiator can authenticate using post-quantum signature. So here it goes. So in green, we retrieve the ephemeral KEM as already explained, and the initiator already is knowing the responder identity can send the ciphertext of the responder in the first message, but we do no more have here an encryption, and it authenticates itself with a MAC in the second message. And in this case, the responders, the initiator, can authenticate with in the EDO classical way with a signature in the third message. And so here we only have 3 mandatory messages. That's a first proposal to make it more suitable with the traditional EDOC protocol. A second proposal in a more classical case is when so we return to a more classical case, and this time we suggest the authentication for the responder with a KEM and a signature. So in fact here in the second message highlighted in orange, the responders provide a signature of a message that the initiator can retrieve locally on its side. And so at the end of when we receive the second message, it can already authenticate the responder and send him in the third message the associated ciphertext. And also in red, it's authentication. So in this case, we do no more have a 4th mandatory message. We only have 3 mandatory message, and the only fact here is that we have 1 more signature in the second message, but we do no more need to compute a MAC on each side. So it only heavier a little bit the second message with this signature, but not the computational part on each side. So we have variant. In fact, the 3 other protocols that we propose in the draft are some variant of that one protocol. I mean, by using signature and KEM combined at the same time. So I will not describe all of them. That was an example. Maybe going on security consideration. So at the end of each handshake, of course, we have both endpoints are assured that they have securely compute the same session key and that securely authenticate. The the combination of a KEM and a signature also simplify the authentication delay and increase the session key security in case where, for example, a participant becomes compromised in a post-compromise security situation, for example. As for the traditional EDOC, we have forward secrecy, downgrade protection, and transcript hash banding. One point I would suggest it's about the identity protection property. Something that I read on the Cotier and Ponchval analysis about the security property modeled, is that it would not always fit correctly or would be able to adapt to this new post-quantum version of EDOC, and also in the draft that were presently produced by Lydia. So maybe we can suggest a more global approach based on PPAK. And just for a comparison, quickly about the byte analysis, I just added that. It's not in the draft, but it's to have it in mind that based on what was done of EDOC, I retake the same structure. We have this global comparison of the proposal we done on the byte of each messages. So the size of each messages is really increased only by the post-quantum cipher suites considered, not the message structure themselves.
Thank you, Clement. Maybe very quick question from John. We are already.
Yeah, it's a high-level question on both of these last draft. Now we have a new charter. How do we progress with the PQC work? I think Lydia gave a quite nice overview of the different options. I think the key exchange, ephemeral key exchange, is quite straightforward, or when you have signature and PSK authentication. What needs more work seems to be the KEM authentication. There's many solutions and many design options. How do we progress with that? Could we have some design team or some interim meeting offline? Seems we should progress what we want to do.
Yes, yeah, so that's a good point. So we have a new charter which allows us to work on quantum resistant ad hoc methods. So I would propose an interim meeting before Vienna that is specifically dedicated to quantum resistant ad hoc, that we can use as an opportunity to discuss exactly how do we proceed on this issue, because we are on top of the hour and we are out of time today. But what I do see is that, as you were saying, John, key exchange seems to be straightforward. We have an individual draft on that, so it would make sense to progress this fast. And then we need to decide what exactly gets standardized in terms of KEM-based authentication for ad hoc. So I propose that we schedule a meeting before Vienna, so midway between now and Vienna, so sometime in May. And we discuss these issues further there. Do we have any other opinions on this subject? The queue is locked, so I will unlock it in case somebody wants to comment. So I hear no opinions. So I would take that as if we agree on the proposed way forward with the interim meeting. In parallel to that, I would propose to form a design team meeting on quantum resistant ad hoc, and perhaps we can start with that immediately, and have the presentations of the design team in the interim meeting in May, such that we use the time wisely between now and the interim meeting, in order to progress with these issues and form consensus in the working group on what exactly needs to be standardized. Does that work for everyone?
Yes, for me.
Okay, so we are 3 minutes late. So we had one more agenda item, that is Meiling's draft, but I don't see her in the room and we are late anyway, so we can perhaps take this presentation either for Vienna or for the interim, depending on the interest of the audience. We will, as chairs, we will consult on that and we'll come back to the working group. So I would like to thank everyone for attending today's meeting and for the productive discussions. So there are several action items. I believe they're captured in the minutes, and we will be publishing these minutes, and the recording will be published on the list following the meeting. Thank you all.
Thank you all. See you soon. Thank you, Melissa.
Final note: I would just like to thank Paul for serving as the AD in his 2 terms, and to welcome
Christopher.
Christian. Yes. So Paul, thank you very much, and Christian, welcome.